Hello? Hi, did you do the question? Did you manage to do the question? Just send a message, and if you can hear me properly. Can you hear me? Okay. I want to know if you can hear me properly there. Guys, can you hear me? I want to know so I can start. Okay. Okay, guys, so we can start. We're going to solve this question. I said yesterday it's question 6 from the material I gave you. This is a test run, so it's the first time. If everything goes well, next week we can do it maybe 2 questions. So it's up to you what you want, okay? So let's solve this question. I hope you went through it and you answer. Otherwise, it's a waste of time, okay? So the question 6 said the diagram below show a point charge A with charge of negative 4 times 10 to the minus 6 coulomb and 2-point charge M and N. Now note that the only charge there is A. M and N are points, okay? So that is important. 6.1 define electric field at a point in words. And then guys, the definition is going to be that one. The electric field at the point is the electrostatic force experienced per unit positive charge at that point. This is the formula, and that formula is going to be given to you in the exam. All right. So if you think you forget the definition, all you have to do is to go to that formula and read the formula. Electric field at the point is equal to force per unit positive charge at that point. Okay? So I hope you are with me. I hope you are with me here. All right? So let's go to the question. Let's go to the question. The next question said, draw the electric field pattern due to the point charge A. So it's only for A, because A is the only point here. All right, so I draw this one here. I hope you can see properly here. All right, so we're going to have here on this point the charge. Remember, we're drawing only for A, and it's a negative charge. Right. Now, when you have only one charge, that electric field are lines straight that going towards the charge, and this is important. The lines must go straight towards the charge, okay? So, for instance, I'm going to draw a line there, and so, and they must touch the charge. Right, we can draw more if you want. Remember, the more lines you draw, the more that one is wrong. Let me see if I can erase that one. Let me clean that one. The more lines you draw, the more probability of making mistake. So the direction is in, because it is a negative charge. All right, so note those lines must be straight lines towards the charge. All right, now this one was, let me see how many marks. There were 2 marks for the definition, which you, I guess, all got, and there is 2 marks for the drawing. That is the drawing. Now, 1 mark would be for the direction. That is important. Then you will get a mark for the direction and a mark for the lines that are straight and touching the charge. So they must be straight and touching the charge. Let me get my coffee, you know. Okay. So there we go. I hope you are with me, guys. You can just send a message and let me know if there is something. Question 6. So we go back to the question. All right. The question says, at what point, and let me just move my my image a little bit up. At what point M or N is the magnitude of the electric field due to the point charge A greater? Explain your answer. Now, in this case, we are dealing with the non-uniform electric field. All right, in which the formula for that one will be this one. Electric field at the point is equal to K charge divided by the distance squared. That is the formula we're dealing with here. Okay? Let me just take this one, put it back there, and then lock it here. All right, so now from here, what you can see that the electric field is inversely proportional to the square of the distance. It means the one that is closer to the charge will experience a greater electric field, right? The one that is further apart will experience a smaller electric field. So if we represent the electric field on those points, at N, you can see it's going to be pointing towards the charge. That is electric field, let's call it N. It's a vector quantity. And then at M is also moving, or pointing, it's not moving, pointing towards the charge, but then is smaller, right? So this one is electric field M. There we go. Now the question doesn't say this one. This one needs to go a little bit more. The question say, if we go here, let me just, the question say at what point is the magnitude? Let me move this one again back here. The magnitude of the electric field due to the point charge A greater. So the answer is greater at N. Why is greater at N? Because it's closer to A. The distance is less. So if the distance is less, then the electric field is greater. All right. So that is what you have to say here. It is N because it's closer to A, and then you have to say that the electric field at a point is directly proportional, like we wrote on this point here. The electric field at the point is inversely proportional to the distance squared. That will give you the final mark for that question. That is a very good question. Okay? So I hope you are with me. Eh? Right, so far, so good. This is the first part of the question, guys, and if you do this part of the question, then you should be already safe to pass this exam. Okay, because we have 2 and 2 is 4, and this one will be another 3 marks. It will be like 7, 8 marks for this one. I'm not sure if it's 3 right now. I deleted. You have it there with you. Okay, so this is the first part of the question. I just want to know if are you following me? I want to know if is any question about this part. No questions? Okay. Right, we can go then to the next part. Okay, let's go to the next part. Let's go to the next part. Right, now the next part is question 6.4, and now is when the calculations begin here. They say a positive point charge B with a charge of positive 8 times 10 to the minus 6 coulomb is placed at point M. So now M is not going to be a point no more. Let me just edit there. M is going to be a new charge, also 3 meters, but this one is a new charge, and that charge is a positive charge with a magnitude of, let's call it here, 8. I'm going to write it, I'm going to show you just now, guys, times 10 to the minus 6 coulombs. Okay, that one is the new charge. There is no anymore a point, now it's a charge. Okay, point a charge A and B exert forces on each other. Yes, remember you also have like a summary, guys. You have like a summary, let me show you, which you can also look for the definition. There is the drawing of the charges, etc., etc. Okay, so we're going back to the equation, We are right here. Now, question 6.4.1, there's another 2 marks that you all can get. You make sure you get those marks because they are quite simple, those marks. Okay? They say, state Coulomb's law in words. So it must be in words. All right. Now, Coulomb's law, it is at the front, as I said. So let me show you. That is Coulomb's law. The magnitude of the electrostatic force experienced by one point charge on another point charge is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. This bracket means that you don't have to say it. So you don't have to say of the magnitudes. That can be omitted. Now, if you look at the formula there, that formula is the law. All you have to do is to be able to read the formula. The force is directly proportional to the product of the charges and inversely proportional to the square of the distance. So with that formula, you can actually state the law. All right? So far, so good, right? Moving on. Let's go to the next question. I hope this one is clear. This one is a definition. You all have to learn the definition, guys. You all have to learn the definition. Okay? So let's go to the question here. Now, the next question says calculate the electrostatic force exerted by charge A on B. Now, for this one, we do have to use or apply Coulomb's law. All right, so let's go here and solve that question real fast. Okay, so here we have that the force is equal to K, the product of charge A, charge B, divided by distance squared. That is the formula. All right. So if you write the formula, just by writing the formula, you get 1 mark. Then you get 1 mark. And you all can get that mark. Okay. So now let's substitute what we have here. K is 9 times 10 to the 9. Charge A is -4. You do not substitute the signs in this formula. You do not substitute the signs in here. So it's going to be 4 times 10 to the -6 times 8 times 10 to the -6 divided by the distance, which is 3 meters. It's already given in meters. You don't have to convert anything. So everything divided by 3. Right. Now what we get here, let me calculate. I want to do this one real fast. We get here with my calculator is 9 times 10 to the 9 times 4 times 10 to the -6. No, I make a mistake here. Times 8 times 10 to the -6 divided by 3 squared. Okay, I want this one in scientific notation. 7. Guys, I got 3,2 times 10 to the 5. 3,2 times 10 to the 5 Newton. All right, that is what I get. I have the answer somewhere here, but I wanted to calculate it. 0,032. So there is something not right. Maybe the the square. Here is the square. Guys, look here. Square. There we go. There we go. It's the square. So that one normal is 2. Okay, I don't get that answer there. Times 10 to the 9. Is the answer in the solution wrong? I don't get that answer, guys. 0.32 towards 0.8. I don't get the same answer as the memo. 0.032. I don't get the same answer as the memo. Right? Let me recalculate. Maybe I make a mistake here. To the 9 times 4 times 10 to the -6. 6 times 8 times 10 to the minus 6 divided by 3 square. 0,032. Yes, I did calculation wrong with the calculator. 0,032. There we go. Now it's fine. So here you will get another 2 marks. 1 mark for the substitution, and be careful, look here what happened to me, and 1 mark for the final answer. That's it. Yes, thank you. Thank you, Copano. You're looking carefully, né? I did put it later on. I noticed when I substitute. So you are actually looking. All right, so let's go to the next question. So this one is the solution of this one. Be careful with that square, right? So let's go to the next one. Now the next one is the one that can give you trouble. Say calculate the net electric field at point N. All right? Yeah, I see you get the answers. Nice. At point N. So we're going to calculate now at point N. Now at point N we have 2 charges interacting there. If we go to the question here, you have, at this point you will have 2 charges, A and B, which is on that side there. Okay, so let me just quickly clean here so I can show you the drawing. Okay, so there we go. Now here we have, at that point we have the electric field due to A and the electric field due to B. So at this point here you will have let's see, electric field A. This charge here is negative, so it will be pointing to the right. Okay, that is electric field due to charge A. So let's write it here, A. Okay, and then the electric field due to charge B, note charge B is positive charge. So this electric field will be pointing to the left. That is electric field B. All right, so we have now these 2 electric fields are pointing in opposite direction. All right, so we are dealing with vectors once more here. We're dealing with vectors here. Let's see. Net electric field is equal to electric field A plus electric field B. This one is vector addition, so everything is positive. Do you understand? I hope you understand. You can write messages there. I'm looking at the messages. Okay? So now, because we have the electric field pointing in different directions, we have to select which one is going to be the positive direction. All right, guys, A is closer to the point charge, so it's greater. So it's better to say right is positive. Let's do it somewhere here. Let's write right is positive. Right is positive. It means the electric field due to A is going to be positive, and the electric field due to B is going to be negative. Not because of the charge, but because it's pointing in the other direction. All right? So I hope we are clear here. So now what we're going to do, we are going to calculate the electric field for A, and we are going to calculate the electric field for B, or due to charge B, let's say, for instance. Let me just take this one quickly and move it here. There we go. So we can solve in that part there. All right, so we are going to take here now, and we're going to say in this corner, E A is equal to K QA divided by distance A square, the square. All right? Now be careful. If you substitute here, or instead of an E you write an F, you get 0. You get no marks, guys. So make sure you write an E. That one is for E, this one here is for F. Okay? I saw last time in the class some people writing E here. That will give you 0 automatically. If you write an F here, you get 0 automatically. So guys, the rest is substitution. EA is equal to K, 9 times 10 to the 9. All right? Times, let me maybe move it a little bit down, guys. move it a little bit down here. We get that E8 is equal to 9 times 10 to the 9 times charge A is -4. You do not substitute the signs here, so it is going to be 4 times 10 to the -6 divided by the distance, which is going to be, remember, it's from A to the point N. All right, this one was 1 meters. So from A to the A is 1 meter square. Okay, and then the rest is the substitution here. Okay, that is the substitution there. Let me see if I calculate quickly, and let's see if we get the same answer. I got here, that is 9 times 10 to the 9, no, times 4 times 10 to the -6, divided by 1 square, and I get 36,000. 36,000, let me just check here. I want to make sure. $36,000, yes, you should get 36,000. That is the correct answer. 36,000. You can convert it into scientific notation if you want. 3,600, 36,000 there. This one is Newton Coulomb. Okay. Let me just move here a little bit down. Sorry there. That is the answer there. Okay. There we go. That is the answer. So we calculate now the electric field A. We have to do the same and calculate the electric field for B. All right, with the same formula, but instead of A, it's going to be B. Maybe we can do it on this side here. We don't need that one anymore for now. We can do it on that side, and let me just move this one now to this corner here. You don't need that. You don't need my face there. All right. So we have here that E is equal to K QB divided by distance squared. All right, there we are. When you substitute, you will get that this one is equal to 9 times 10 to the 9 times, this one is a 9, it doesn't look like a 9, it looks like a 3. Here we go, 9 times 10 to the 9 times charge B is 8. 8 times 10 to the -6. There we go. Now the distance, be careful, because it's 3 plus 1. It's from B to N. So the distance is going to be now 4 square. All right? That is 4 square. Yes. Yes, that is what we get. 3,600. Are you sure? I didn't get 3,600. Let me see. Let me recalculate quickly. I get 36,000. I get 36,000 times 10 to the 4. 1, 2, 3, 4. Yes, times 10 to the 4 is 36,000. Okay, guys, you can play with the calculator and change them from normal to scientific notation and compare the answers. Okay, it should be 36,000. So anyway, here now, when we calculate this one, what we get, let me see quickly, is 9 times 10 to the 9 times 8 times 10 to the -6 divided by 4 square. And I get 4,500 only. Okay, we can write it here. This one is equal to 4,500 Newton per Coulomb. Okay, That is the answer. So these are the answers we have. These are the answers we have for each of them. Okay? Yes. 4,500. Thank you, Pilile. So now, guys, we come in and we substitute those here. Because already we have. All right, remember the direction becomes because of the drawing here. Direction comes because of the drawing, but not because of positive charge or negative charge, okay? So now here, we say, write this positive, yes. Write this positive. So we have that EA, we say on top there was positive. So EA is 3,000, let me see here, I have enough space. 36,000, right? 36,000 minus, because EB is negative, minus 4,500, and that will give you the net electric field. Okay, the net electric field here is going to be equal to, I have to manage the space next time. Next time I'll manage the space, guys. Okay, so this one will give you minus 36,000. It will give you 31,500. 500 Newton per Coulomb. That is the magnitude. This one is the answer here. Okay? That is the answer. In what direction? Well, the answer is positive. We said right is positive. It means this one is to the right. To the right. There we go. And that is the answer for the question. That is the answer for the question. It's not so bad. You can get a lot of marks here. Okay. Now here, in terms of marks, you need to know where the marks are allocated. You will get 1 mark for this formula, wherever, either for A or for B, for one of the two. So it's not that you get both of them. You will get 1 mark for the substitution of the B as well as the substitution of the A. And then you are coming to this part here when you subtract, and the final answer with the direction if they ask for the electric field. And guys, this one is the question. Okay? I think it went well. It can help. It can help if we do it often, and we can mark 1 or 2 questions. It doesn't need to be 1 question. It's entirely up to you. You can also suggest, yes. You can suggest what question you want to do, what topic you want to do, and the length. It's entirely up to you. Okay? So I'm going to wait if there is any answer. Remember, there is a delay from my stream to the messages. So I want to know if there is any question. Any question. That is the end of this video. We go here to question 6.4. Let me just take off this one. That was the question. Note here, they say calculate the net electric field. It means the direction must be there. If they said calculate the magnitude, then no direction. Yes, that is what we got. So I'm just waiting for questions. It's entirely up to you guys. And I really thank you. It went well. For the 6 learners are connected. If it's 1, well, I'll do it with 1. That one is the only one that want to improve. That's my coffee. Guys, if there's no question, then we are done. If there is no question, we are done. And then I thank you. I'll see you on Monday. I hope there is water. If it's not water now, we don't worry, because we can always continue with the work via this option. Okay, it's given to you in the question, Pilile. Did you go to the question here? It was one distant, one meter here. Okay? It was given to you in the question. Because it's A. So from A to the point N is 1 meter. It's given to you. It's given to you in the question. It's not a problem that's on there. No? Are you fine, Pelile? Thank you, boy. Nice you join. I hope it helped. Remember, we must try to do some challenging questions, so you can just let me know which one you want to do next time. The whole solution there. Well, guys, so if there's no more question, then I hope you enjoyed your weekend without water. I hope the water also comes. But then I'll see you next time. Thank you for everything. I hope it helped. And then I'll see you next time. See you.